Hello everyone. Welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have already understood what is a deterministic finite automata. And now in this lecture, we are going to understand transition diagram and transition table of DFA. So we have only two topics to discuss today, and that are the first one is transition diagram of DFA, and the second one is the transition table of DFA. So let's start our discussion with our very first topic, that is transition diagram of DFA. Here you can see an example of transition diagram of DFA. And this example we have already seen in our previous lecture. There we have verified that this is a valid DFA. Why? Because this transition diagram satisfies all the requirements of a DFA. In this diagram, you can see that there are multiple parts like these circles, these arrows, this self loop, these symbols, and so on. So now we are going to understand each of these parts of this DFA one by one. So the most prominent part that you can see in this diagram are these circles. So what are these circles? These circles are the representation for the state of a DFA. That means these three circles represent the three states of DFA, that are Q0, Q1 and Q2. Now you can see that this circle is a little bit different from other circles. Why? Because this circle also has an inward arrow with it. So this circle with an inward arrow with it is also a type of state, but this is a special type of state, which is called as the initial state. So the initial state of a DFA is a state from which the processing of an input string starts. Now this is also a different state. Why? Because if you see, these two states have only one circle, while this state has two circles. So a state having double circle is a representation for the final state of the DFA. And we know that if the processing of an input string stops at the final state, it means our input string is accepted by the DFA. That is why final state is also called as the accepting state. So now we have understood that Q0 is the initial state, Q2 is the final state, and Q1 is just a normal state. So let's move towards the next part of the DFA, which is the transition between the states. So if this is the first state, this is the second state, then this arrow represents the transition from first state to second state. And in this diagram, we can see that there are multiple transitions. This is a transition from state Q0 to Q1. This is a transition from state Q0 to Q2. This is a transition from Q2 to Q0. This is a transition from Q2 to Q1. And this is a transition from Q1 to itself. So I hope transition between the states is clear to you. Now if you notice in this diagram, every transition is between the two states. But there is a special type of transition that is involving only one single state. This transition is originating from the state Q1 and is ending on the same state Q1. And this special type of transition is called as a self-loop transition because it is involving the loop on the same state. So this is the representation for a self-loop. And this self-loop transition can be repeated any number of times. If I talk about this normal transition, suppose I am at the state Q0 and after getting the input A, I reach the state Q1. Now, I cannot repeat this transition again once I reach the state Q1. But if I talk about this transition, suppose I am at the state Q1 and after getting the input A, I will get back to the same state Q1. Again, if I get the same input A, I will reach back to the same state, that is Q1. That means this transition can be repeated any number of times. So I hope you have understood normal transition between the states as well as this self-loop transition. So let's move towards the next part of this DFA, that are input symbols. So A and B are used as the input symbols in this DFA. These symbols are the part of our input string. The next part of the DFA is the state identifiers. Here, Q0, Q1 and Q2 are the state identifiers because they are used to identify the three states of the DFA. They are the names given to these three states of the DFA. So now I hope you have understood transition diagram and its various elements. In this way, we are done with our very first topic, that is transition diagram of DFA. Now let's proceed with our second topic, that is transition table of DFA. Now before understanding what is a transition table and how to construct it, let's first understand the need of transition table. So we already have the transition diagram, then why there is a need to construct the transition table also? The reason is that our computers cannot easily understand the diagrams and visuals. Computers work better with the structured data, and tabular data is more structured and organized as compared to the visual data. That is why we convert the transition diagram into the transition table. This is the first reason why we construct a transition table. The second reason is that when we will explore the further topics like the conversion of NFA into DFA, the minimization of DFA, and so on, then we will find that understanding transition table is much more convenient and easier as compared to transition diagram. When the number of states will increase, transition diagram will look much more complex, but it is very easy to understand the transition table for the same transition diagram. That is why we convert a transition diagram into transition table. So I hope the need of transition table is clear to you. Now we will understand how to construct a transition table for a given transition diagram. So here we have our same transition diagram that we have just understood. Now we will convert this transition diagram into a transition table. Here is the structure of a transition table. Let's understand this structure. In the first column, we have written all the states of the transition diagram. So we have only three states, Q0, Q1 and Q2. So we have written Q0, Q1 and Q2. If there are more states, we can write them after Q2 like Q3, Q4, Q5 and so on. Similarly, in the first row, we have written the input symbols. Here we have only two input symbols, A and B. So we have written A and B. If there were more input symbols, we can write after B, C, D, E and so on. So this is a basic structure of a transition table. Now this arrow before Q0 represents that Q0 is the initial state, while this asterisk before Q2 represents that Q2 is the final state in the DFA. So these are the current states represented by Q, and these are the input symbols represented by sigma. And now we will fill the next states in these empty cells. So if the current state is Q0 and the input symbol is A, then what will be the next state? Let's check in the diagram. If the current state is Q0 and the input symbol is A, then the next state is Q1. So we will write Q1 here. Similarly, if the current state is Q0 and the input symbol is B, if the current state is Q0 and the input symbol is B, then the next state is Q2. So we will write Q2 here. Similarly, if the current state is Q1, on getting the input symbol A, the next state is Q1. And on getting the input symbol B, again the next state is Q1. If we talk about our last state, which is Q2, on getting the input symbol A, we reach the state Q1, and on getting the input symbol B, we reach the state Q0. In this way, we have constructed our transition table for the given transition diagram. So I hope you have understood transition diagram, transition table, and the conversion of transition diagram into a transition table. Now we will solve one problem in which we will design a DFA, that is, the transition diagram of the DFA, and after designing the transition diagram, we will convert that into transition table. So let's see the problem. The question is that we are required to design a transition diagram and a transition table of a DFA that accepts all strings of zeros and ones over sigma equals to 0, 1. That means we are required to design the transition diagram and transition table of a DFA that will accept any combination of 0 and 1. So let's start designing our DFA. So first of all, we will have our initial state, let's say Q0. Now, this DFA should accept every possible combination of 0 and 1. That means a single 0 should be accepted, a single 1 should be accepted, multiple zeros should be accepted, multiple 1s should be accepted, and even any combination of 0 and 1, taking 0 and 1 in any order and repeating any symbol any number of times should also be accepted by our DFA. So, let's continue making our DFA. Always keep in mind that while constructing a DFA, initially we consider the simplest possible string. And the simplest possible string in this case that should be accepted by this DFA are a single 0 or a single 1. That means on getting the input symbol 0 or 1, we are getting the complete string that is 0 or 1. So we will directly reach the state Q1, which is an accepting state from Q0. In this way, our string 0 or the string 1 will be accepted by this transition diagram. But what about the strings made up of multiple zeros or multiple 1s? How will they be accepted? Let's take an example of a string containing multiple zeros, like 0, 0, 0. So let's see how to process this string. The first 0 will be processed using this transition. But what about the other two zeros? For the other two zeros, we will create a self loop of 0 over the state Q1. And I told you that self loop transition can be repeated any number of times. Now let's check how we will process the string 0, 0, 0. 0, 0, 0. In this way, the first symbol 0 is processed by this transition, while the other two zeros are processed using this self loop. And the string processing is ending at the final state. That means 0, 0, 0 will be accepted by this DFA. Similarly, if I take an example of string containing multiple ones, for example, 1, 1, 1. For that also we need to create a self loop of 1 over the state Q1, because only the first one will be accepted by this transition. The other two ones will be accepted by this transition. So the string 1, 1, 1 will be processed like 1, 1, 1. In this way, we can accept a single 0, a single 1, multiple zeros, multiple 1s, and even any combination of 0 and 1. So this is the transition diagram of the DFA that will accept all possible combinations of 0 and 1. Here you can see that this 0 and 1 are written using a comma-separated notation. So these two transitions can also be combined and written as a comma-separated notation, like this. So this is our complete DFA. Now we will construct a transition table corresponding to this DFA. So this is the transition table for this DFA. Here you can see Q0 and Q1 are the two states of the DFA, where Q0 is the initial state and Q1 is the final state. And 0 and 1 are the input symbols of this DFA. If the current state is Q0 and the input symbol is 0, then the next state is Q1. If the current state is Q0, the input symbol is 1, then the next state is again Q1. Similarly, if the current state is Q1, on getting the input symbol 0 or 1, the next state will be Q1 only. In this way, we have constructed the transition table for the given transition diagram. Now, for your surety, let's test few more strings to check whether we have constructed a valid DFA or not. So our first string is 0, 1. Let's process this string. 0, 1. So the string is ending at final state. That means this string will be accepted by this DFA. Let's take another string. 0, 1, 0, 1. 0, 1, 0, 1. Again ending at final state. That means it will be accepted. The next string is 1, 0, 0, 0, 1. So 1, 0, 0, 0, 1, ending at final state, and hence will be accepted. The last string that we have taken is 0, 0, 1. Let's process it. 0, 0, 1. It will also get accepted by this DFA. That means every possible combination of 0 and 1 will be accepted by this DFA. So this is how we have solved a complete problem on construction of the transition diagram and transition table for a DFA. In this way, we have completed our second topic also, that is transition table of DFA. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.